So, beta, today what we are going to do is I'm going to familiarize you with the basics of celestial navigation. So, we will try to get familiar with basics of altitude correction, then almanac, what all information is available to us in the almanac, how do we work with R angles, GHA, LHA, SHA, what is chronometer ambiguity, how the chronometer ambiguity is resolved. So then how do we calculate the azimuth of celestial bodies using the ABC method? How do we calculate the amplitude? What is the formula? How do we name the azimuth and amplitude? So these basic fundamentals we are going to strengthen. ये सब भी आप पहले कर चुके हो, but I am going to revise them all so that there is no doubt in your mind. Because अगर इन चीज़ों में doubt आ जाता है, then the bigger questions start to get wrong. So that is the first thing which we will do. And once we are comfortable with this, then we will move on to site solving methods. So we have total 5 site solving methods: Marpas, long by Cron, intercept, X meridian, and Polaris. So one by one we are going to cover all these 5 methods. So let's see how much we can cover today, maybe 1 or 2 methods. So that is the plan now. We are moving on to question number 5 and 6 of our paper. Both these questions will involve these concepts. For today's class, beta, keep the Nautical Almanac with you. So as I explain what all information is there, you can keep referring to the Almanac and keep getting familiar. So have the Nautical Almanac handy with you. Okay, all right, beta. So we are basically trying to convert the 3-figure notation to quadrantal notation. Right, beta? इसी में issue आ रहा है ना?
Right, sir. Right.
Okay. तो पहले यहाँ पे नॉर्थ साउथ ईस्ट वेस्ट मेंशन कर देते हैं. नॉर्थ is 000, ईस्ट is 090, साउथ is 180, एंड वेस्ट is 270. तो अब बेटा मुझे कोई मुश्किल सा 3-फिगर नोटेशन कोर्स दो जिसको क्वाड्रेंटल में कन्वर्ट करना है. कोई डिफिकल्ट वाला दो.
335.
ओके, 335. दिस इज द 3-फिगर नोटेशन कोर्स और हमें इसे कन्वर्ट करना है क्वाड्रेंटल नोटेशन में. तो पहले तो बेटा 335 को इस डायग्राम में फिट करते हैं. ओके, सो 335 वुड कम समवेयर हियर. राइट बेटा?
Right.
ओके, सो ये 335 हमने यहाँ पे फिट कर दिया. अब बेटा ये नॉर्थ डायरेक्शन के पास है या साउथ के पास है?
नॉर्थ के पास.
नॉर्थ के पास है. तो आप नॉर्थ से शुरू होके 335 तक ये जो एंगल है बेटा, इस एंगल को मेजर कर लो. ओके, 000 जो है वो 360 भी होता है. सो कैन यू टेल मी बेटा व्हाट इज दिस एंगल?
360 minus 335, sir.
वेरी गुड. कितना हो गया ये?
25.
360 minus 335, 25 degree.
वेरी गुड बेटा. सो ये 25 डिग्री एंगल आ गया. ये हमारी कन्वर्जन भी हो गई. सो नॉर्थ 25 डिग्री वेस्ट कन्वर्टेड इनटू क्वाड्रेंटल. नॉर्थ 25 डिग्री वेस्ट. क्लियर हुआ बेटा मेथड?
हाँ जी सर. So we have to take only the north and south. अभी जैसे कि साउथ में अगर होगा तो फिर साउथ वाले का पास वाला देखना है.
That's correct बेटा, that's correct. कोई साउथ की एग्जांपल भी ले लो. Give me any course.
200.
135.
135? Okay.
हाँ जी.
So 135 is going to come somewhere here.
185 मैंने 125.
Okay. So अब ये किसके पास है बेटा? साउथ के पास है या नॉर्थ के पास है?
साउथ के पास है.
साउथ के पास है. तो साउथ से मेजर करेंगे एंगल अप टू दिस कोर्स. दिस इज द एंगल व्हिच वी हैव टू मेजर. सो हाउ मच इज दिस एंगल बेटा?
45.
45 sir.
वेरी
South.
गुड.
45 east.
वेरी गुड बेटा. सो ये एंगल है 45 and the course becomes south 45 east.
Excuse me, sir.
हाँ, go ahead बेटा. You are
What is
excused.
Sir, what is that he is asking, south or north? Can you explain in English?
Beta, he is not asking anything. He had a little doubt in converting three-figure notation codes to quadrantal codes.
Yes, sir. Let's say
Do
now
you-
he given 135 and now we are asking south or north. What is that?
Beta, do you have any doubt in conversion of three-figure to quadrantal, or you can do it?
Yes, sir.
You have doubts?
No, no.
You don't have doubts, na?
Okay.
Then forget about it, beta. Forget about it. कुछ नहीं किया हमने. We did not do anything. Okay.
Sir, in case of southwest direction, suppose 220 so figure, sir. So 180
Okay.
degree.
Okay. So 220 is the three-figure notation course, and you want to convert it to quadrantal notation. So let's fit 220 here. 220 is going to come here. Let me pick up another color now. 220 will come somewhere here. Agreed?
Yes, sir.
Now you have to check this 220 is closer to south or closer to north.
Sir.
Closer to south. So from south direction, measure the angle up to your required course. What will be this angle?
40 degrees, sir. No,
Very
southwest.
good. So south 40 degrees west. From the south direction, if you go 40 degrees towards the west direction, this is the course which we are talking about. So this becomes south 40 degrees west. Clear, beta?
Yes, sir. Thank you, sir.
Understood, sir. I was getting confused with even the east-west. I was taking from east-west also, इसलिए वो गलत हो रहा था.
So if you
90
take east, east can be written as exactly east, 090 east. Or if you want, you can write north 90 degree east or south 90 degree east. Okay. So usually we do not mention north or south with east. 090 is mentioned as only east.
Yes, sir. No, I was taking the direction which we are taking from north to south. मैं east west से ले रहा था, इसलिए I got confused.
Okay,
So
okay,
every
okay,
time we
all
have to
right.
take it from only from the north south line.
That's correct, beta. The reference is always either north or south.
Yes,
Right,
sir.
sir.
My doubt.
Thank you, sir. Thank you.
Okay, beta. All right. Okay, great. So shall we move on to our today's topic, beta? All of you have almanacs ready with you?
Yes, sir.
Okay. All right. So we are going into the basic fundamentals of celestial navigation, altitude correction, almanac information, amplitude and azimuth, chronometer, ambiguity, all these things. How to work with R angles, LHA, GHA, SHA, right ascension, all these things we'll see one by one. So let's go, beta. I will put up the presentation. Give me a minute. We are now going to understand the concept of altitude correction in celestial navigation. In celestial navigation, we use the celestial bodies, that is the sun, stars, planets and moon, to calculate position lines. Now for obtaining position lines using these celestial bodies, we need the true altitude of a celestial body. The instrument which is available to us for obtaining the true altitude is the sextant. Now the altitude which the sextant provides us is known as the sextant altitude. This sextant altitudes needs to be corrected and converted into the true altitude of the body. And altitude correction is the process of converting or correcting the sextant altitude to obtain the true altitude. Let us now see step by step how do we convert the sextant altitude to the true altitude. Now once we obtain the sextant altitude of the body, the first correction which is applied to the sextant altitude is the index error. Index error is basically the error of the instrument. Now sextant is a very delicate and precise equipment. There are a lot of moving parts in the sextant, because of which it can have an error of its own. Now this index error is denoted as either on the arc or off the arc. When we are applying this index error, on the arc index error is subtracted or is negative, and the index error which is off the arc is to be added to the sextant altitude, or it is positive. To memorize it easily, you can remember this index error as a light switch. If the switch is on, you put it off. Putting it off means negative correction. And if the switch is off, you put it on. Putting it on means a positive correction. Now, as far as our examinations are concerned, this index error is always provided to us in the question, and we need to apply this index error as per its sign. Now, once the index error is applied, the sextant altitude is corrected to the observed altitude. The second correction which we apply to the observed altitude is the dip correction. This dip correction is based on the height of eye of the observer. The observer is above the sea level, so the height of eye above the sea level generates this dip correction, and this dip correction is always negative. This dip correction is given in the first page of the Nautical Almanac in the dip correction table, and it is picked up from that table and applied as such. Once we apply the dip correction, the observed altitude is now corrected to the apparent altitude. Now to this apparent altitude, we have to apply 3 more corrections. These corrections are: number 1, the refraction correction. Now refraction is a physics principle which says that when a ray of light travels from 2 different medium having different densities, the ray of light either bends towards the normal or away from the normal depending upon the density of the mediums. Now when we observe any celestial body, we are able to observe it because some light from that celestial body reaches to our eyes. This light coming from the celestial body has to pass through the space as well as the atmosphere before it reaches our eye. Now when it passes through space, space has 0 density, and from space when it enters the Earth's atmosphere, now atmosphere has some positive density. Now when it is entering from a rarer medium to a denser medium, rarer medium is space and the denser medium is the atmosphere, the ray of light bends towards the normal. And because of this, all the celestial bodies appear slightly higher than where they actually are. And this is the reason why the refraction correction is always negative. The second correction which is applied to the apparent altitude is the semi-diameter correction. Now when we observe the celestial bodies, star as well as planets, they appear as point objects, so their altitude can be taken directly. But the sun and the moon, they do not appear as point objects. The sun and moon appear as disks. Now when we take the altitude of a body, the altitude is taken with reference to the center of the body. Now we are not able to see or find out or pinpoint the center of the sun or the moon. What we can identify and observe is either the lower part of the sun or the moon, which is known as the lower limb, or the upper part of the sun and the moon, which is known as the upper limb. So when we are taking the altitude of sun or the moon, we take the altitude of either the lower limb of sun and moon, or we take the altitude of the upper limb of the sun and moon. Now from this lower limb or upper limb, when we have to correct our altitude to the center of the sun, we have to apply this semi-diameter correction. This semi-diameter correction is nothing but the radius of the body as apparent or as visible to the observer. So if we take the altitude of the lower limb of the sun or moon, this semi-diameter correction has to be added to reach up to the center of the disk. And if we take the altitude of the upper limb, this semi-diameter has to be subtracted to reach up to the center of the disk. So that is why in case of a lower limb observation, the semi-diameter correction is positive. And in case of a upper limb observation, the semi-diameter correction is negative. The third correction which we need to apply to the apparent altitude is the parallax correction. Parallax is the angle at the center of the celestial body subtended by the radius of the Earth. And this parallax correction is always positive. You can memorize it easily, P for parallax and P for positive. Once we apply these three corrections, that is the refraction, semi-diameter and parallax to the apparent altitude, we obtain the true altitude of the body. This true altitude is what we require for calculating the site of a celestial body, which helps us to obtain a position line. Now these three corrections which we saw, that is the refraction, semi-diameter and parallax, can be applied as a single correction, which is known as the total correction. This total correction is given to us in the almanac in the total correction table for all the celestial bodies, that is the sun, stars, planets, as well as moon. And this total correction can be applied in one go, and all these three corrections are accounted for or taken care of. This gives us a very quick and easy method to obtain the true altitude by using the total correction. Any doubts in this beta, altitude correction? Very good, beta. Great. Moving ahead. Let us now go into these corrections one by one. The first correction which we saw was the index error. Index error is given to us in the question itself. So it is picked up from the question and applied. The second correction which is required is the dip correction. The dip correction is available to us in the dip correction table, which is given on the first page of the Nautical Almanac. You can now see the first page of the Nautical Almanac, and the table highlighted on the right hand side is the dip correction table. You can see the dip correction values are provided against the height of eye. The height of eye of the observer is given in meters as well as feet. So using any height of eye in meters or feet, you can enter into this table and pick up the dip correction from here. You will see all the dip correction values are negative. There is a negative sign, reminding us once again that the dip correction is always negative. Also, if you notice, the values of dip correction are given for a range of height of eye. Like say, for example, if you have the height of eye as 9.5 to 9.9, any height of eye between these figures, 9.5 to 9.9, the dip correction for these is minus 5.5. No interpolation is required in such a scenario. And you may have a doubt that in case your height of eye lands exactly at a critical entry, like say for example, if your height of eye is exactly 9.5, a doubt may arise whether I should pick up my correction as minus 5.4 or as minus 5.5. So in such a situation, when your height of eye matches with a critical entry, please pick up the upper value given in the table, the value which is upper in the table. So in case of 9.5 meters height of eye, the dip correction would be minus 5.4. Any doubts in the dip correction table, beta? You can have a look of the dip correction table in your almanac. Any doubt coming in, let me know.
So if the dip is 9.8, still we will take 5.5.
That's correct, beta. Even 9.9 also will be minus 5.5. 10.0 onward, it will be minus 5.6.
Okay, sir.
Okay, beta. Great. Now, after the dip correction, the next correction which we require is the total correction. Let us see how do we obtain this total correction for different celestial bodies, that is sun, stars, planets and moon one by one. We again go into the first page of the Nautical Almanac. You can see the page on the screen now. The first table on the first page of the almanac gives you the total correction for the sun. You can see the total correction table for sun highlighted now. If you look carefully in this table, the first thing you are going to observe is this table is divided into two different parts. The first column caters to October to March, and the second column gives us the total correction values from April to September. So depending upon what is the month or date on which the site is taken, we will enter into an appropriate column. So whatever date and month is given in the question, we enter into the appropriate column. Now once you enter into the appropriate column, the total correction is picked up from the apparent altitude. So table is entered with the apparent altitude and also the limb of the sun. You will see the values of corrections given against apparent altitude, and there are two columns. One is for the lower limb, another is for the upper limb. So depending upon what limb is given in the question and what is the apparent altitude, we will pick up the required total correction. You will observe that all the total correction given under the lower limb are positive and the total correction given under the upper limb are negative. Now moving on to the stars and the planets. Now stars and planet total correction is given in a single table. The second table in the almanac on the first page itself gives us the total correction for stars and planets. This table is also entered with the apparent altitude of the body, and against a range of apparent altitude, you can pick up the total correction from this table. All the total correction values in the stars and planet column are negative. Now, a special thing which you will observe is that there is an additional correction given for two planets. These planets are Venus and Mars. There are total 4 planets which are used for site solving, celestial navigation, that is Venus, Mars, Jupiter and Saturn. Now out of these 2 planets, Venus and Mars have an additional correction also. You can see there is a range of dates which is given, like say for example in the case of Venus, January 1 to December 10. If the apparent altitude is between 0 and 60 degrees, there is a correction of plus 0.1 minutes. Likewise, for dates falling between December 11 to December 31, The values of additional correction are given against apparent altitude, against a range of apparent altitude. And similarly for Mars, for these specific dates, the values of additional corrections are provided. Now, one important thing to remember is that this additional correction is something which is additional. It is clear from the name that this is an additional correction. So after you apply the total correction, you have to apply this additional correction also. Please do not forget to apply the total correction. Applying only the additional correction to Venus and Mars and not applying the total correction will make the question wrong. Now you may have a doubt that what is the reason
excuse me, sir. Can you
correction for Venus and Mars? Go ahead,
Hello.
Beta. Go ahead.
Sir, in this Venus column, this if you go December 11 to December 31st, this 41 0 to 41 is 0.2, and then 76 6 0.1. Can you explain, sir, when to use this one 76? Or it is
Beta,
together with 41 degrees 76?
I'll tell you. If the apparent altitude of Venus is between 0 to 41, you use plus 0.2 additional correction. If the apparent altitude is greater than 41 and up to 76, you use plus 0.1 as the additional correction.
Okay, sir, but ये 76 कहाँ तक होता है? Only up to 60 डिग्री के बाद तो फिर चेंज हो जाएगा ना सर, लाइक डिग्री?
क्या चेंज हो जाएगा बेटा 60 डिग्रीज के बाद?
जैसे नहीं, अगर जैसे डिग्रीज तो 60 तक ही होता है ना सर, 76 दिया हुआ, तो ये स्पेशल केस के लिए है क्या?
बेटा आपका जो एल्टीट्यूड है बॉडी का, एपरेंट ऑल्टीट्यूड, उसकी मैक्सिमम वैल्यू क्या हो सकती है?
अच्छा, उसकी मैक्सिमम वैल्यू तो 90 तक हो सकती है ना सर?
एग्जैक्टली बेटा. सो 76 तक करेक्शन दे रखी है, 76 के ऊपर भी हो सकती है, उसके लिए कोई करेक्शन नहीं, नो करेक्शन फॉर दैट.
ओके 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 सर, अंडरस्टूड सर, थैंक यू सर.
ओके.
सर ये प्लैनेट्स के लिए
यप, गो अहेड.
पहले लेफ्ट वाला करेक्शन भी करना है एंड देन प्लस एडिशनल करेक्शन.
That's right, beta. That is right. Both of them have to be done.
Okay, sir.
Okay, all right. Now you will appreciate that Venus and Mars are much closer to the Earth as compared to Jupiter and Saturn. Because these are closer to the Earth, they have a substantial parallax. And this additional correction takes care of that parallax correction. Also, Venus and Mars exhibit and show phases. So just like you see the moon in different phases, sometime you have a full moon, sometime a gibbous, half moon or a crescent moon. Likewise, Venus and Mars also exhibit phases. They do not have their own light. They reflect the sunlight, and that's how they are visible to us. So they also exhibit phases. And it is possible that when Venus and Mars is exhibiting a particular phase, you may not be able to see the exact center of the planet. What you are seeing may be slightly higher or lower than the center of the planet. So this additional correction takes care of the phase effect. So this additional correction is nothing but a combination of the phase effect and the parallax effect which is present with Venus and Mars. Any doubts now, beta, in total correction of sun, stars and planets? Very good, beta. Great. Let us now see the total correction for the moon. The total correction table for the moon is given on the last page of the almanac. The total correction for the moon comprises of two parts, the main correction and the HP correction. Upper part of the table gives us the main correction, and the lower part of the table gives us the HP correction. Now let us zoom into these two parts and see how these corrections are picked up. You can now see the zoomed in top part of the table, the first part of the table. Now this first part of the table is entered with apparent altitude of the moon. There are different columns giving us ranges of apparent altitude. The first column gives us a range of 0 to 5 degrees. Next column 5 to 10 degrees. Next one 10 to 15 degrees, and so on. Depending upon the apparent altitude, what we have obtained in that question, we enter into the appropriate column and get the main correction from the top part of the table. Let us understand it with an example. Let us assume that in a particular question we have an apparent altitude of the moon as 6 degrees 30 minutes. Now we can see that 6 degrees will fall in the second column of the table, which covers a value of 5 degrees to 10 degrees. So we enter into the second column. You see 5 degree, and going down you see this is 6 degrees. Now below 6 degrees, if you see on the left hand side, you have the minutes mentioned. So for 6 degree 00 minutes, the correction is 59.5. For 6 degree 10 minute, it is 59.7, and so on. The correction what we require for 6 degrees and 30 minutes is 60.0 minutes. So this is the main correction for a apparent altitude of 6 degrees 30 minutes. You can see that for 6 degree 40 minutes, the correction is 60.2 minutes. And in case the apparent altitude value falls between these two, that is 6 degree 30 and 6 degree 40 minutes, the value of the correction needs to be interpolated. So to make it very clear, if the apparent altitude was 6 degree 35 minutes, the value of the correction would be interpolated and it would be 60.1 minutes. Any doubt in main correction, beta?
Sir, एक और example दे सकते हो सर? Something like 33 degree 25 minutes.
Okay. So you see beta, for 33 degree 00 minutes, correction is 57.5. Right?
Yes, sir.
For 3310, it is 57.4. For 3320, it is again 57.4. For 3330, it is 57.3. Now you wanted it for 3325, right beta?
Yes, sir.
So that would come to, if you interpolate, that would come to 57.35. Okay. But we don't take this correction to two places after the decimal. We keep a accuracy of one place after the decimal. So you will round it off to 57.4 only.
Understood, sir. Understood.
Okay. Great. Let's now see the bottom part of the table. You can see the bottom part of the table on the right hand side now. Now the same column which was entered for picking up the main correction has to be continued to the bottom part of the table also. We entered into the second column. So for picking up the HP correction from the bottom part, we again enter into the second column. You will see every column is subdivided into two columns represented by alphabet L and U. L and U represents the lower limb and the upper limb of the moon. So whatever limb the observation has been taken, we will enter into that particular column and pick up the HP correction value. Now on the left hand side, you will see the HP values are given. This is the horizontal parallax of the moon. HP stands for horizontal parallax. This horizontal parallax can be obtained from the daily page, the date page of the almanac. So let us assume that in this particular question, the HP was given to be 55.5 minutes and it was a lower limb observation of the moon. So we enter into the second column. We go in the column under L, Lima for lower limb, and we go up to a HP value of 55.5 minutes. And you see that the value of the HP correction is 2.2 minutes. So once we obtain the main correction from the top part and the HP correction from the bottom part, both these corrections are added. Both these corrections are positive. They are added to the apparent altitude. Now, after we have applied these two corrections, one more correction needs to be applied if it is a upper limb observation of the moon. If it is a lower limb observation, you pick up the main correction and the HP correction, both positive, both are applied, and the true altitude is obtained, correction is completed. But if it is a upper limb observation, then after applying the main correction and the HP correction, a upper limb correction of 30 minutes is to be subtracted. So after applying these two corrections, if it is a upper limb observation, 30 minutes need to be subtracted. This is known as a upper limb correction, and we obtain the true altitude of the moon. So I'm repeating once again. In case of a lower limb observation, pick up the main correction, pick up the HP correction. Both corrections are positive. We apply them to the apparent altitude and get the true altitude. If it is a upper limb observation, we pick up the main correction, we pick up the HP correction. Both corrections are positive, and after applying these two corrections, a correction of minus 30 minutes is subtracted. Minus 30 minutes upper limb correction, and we obtain the true altitude. Now, what I have explained is mentioned in this part of the table. In case of any doubt, you can refer to this part of the table and see the procedure.
HP value is given in the question, sir, in exam.
No, beta. HP value is given on the daily page. I will show you when we go ahead. I will show you the daily page and the HP value there.
Okay, sir.
Excuse me, sir.
Go ahead, beta.
This in this page there is one column dip page. So
right.
So where we use this column, sir? Only for moon case or it is for different case?
No, it is just given for convenience. Dip remains the same irrespective of which body it is. So the table which was given on the first page, a small part of that table is repeated here. So it is just for convenience so that you don't have to turn the pages. But if you want to refer to any of the tables, the first page table or this table, you can refer to anyone.
So this is only for the reference only, not related with the moon.
Dip correction is independent of the body, beta. It will be same whichever body it is. So this is given only for convenience.
Okay, sir. And the second thing you tell for upper limb, we need to subtract 30 minutes.
That's right.
For each case.
That is right, beta.
Okay, sir. And for planet, only Venus and Mars need additional correction as you explained.
That's right, beta. Correct.
Okay, sir. Thank you, sir.
Here from the on the table you said to add the upper limb value set like next to 2.2 that 2.0 is there. So if it is an upper limb correction, we will add this 2.0 and then subtract 30 minutes.
That is correct, beta. The main correction as well as the HP correction are all positive. Whether it is upper limb or lower limb, both these corrections are positive. In case of upper limb, the negative correction is minus 30 minutes.
Okay, sir.
Sir, one more thing I just want to highlight.
Go ahead.
Regarding moon, this HP correction is basically depend upon GMT or GHA of the moon.
It will depend upon GMT, beta.
But if in question it is not given, because I face like this problem.
Okay. So your doubt
we are
is,
not able to find the GMT, then we have to, how do we find the HP and apply to the in this
okay,
regions in this section? So
okay. So you mean to say there was a moon site question and the GMT time is not
yeah,
given
moon
there?
side question. Yeah.
Okay. Beta, just share that question with me over the group. Let me have a look.
Okay, sir. I will share, sir. Because one question I'm trying to do, and then we are not able to find the GMT, and due to that we are not finding out our HP. So we hold on there, sir.
No problem, beta.
Okay, I will share for
Uh,
that question, sir. Yeah.
these questions will certainly have the GMT time given to you, because whenever a site question is given, then within that site question, the time has to be provided to get the GHA, to get the declination. So it has to be there. So anyway, if you have a
Actually, sir,
question
on
like
that
that,
question, when I asked someone, they said some daily reduction or daily changing of phases of moon. That thing should be come on there, sir, like this, sir.
no, there is nothing like that. You share the question with me. Let me have a look.
Okay, sir. Sure, sir. Hmm.
Okay. Or beta, more doubts?
No, sir. Nothing, sir. That's
Okay, beta. Great. Let us now understand the chronometer time ambiguity. Now, chronometer is a highly accurate clock which gives us the accurate or exact GMT. We can see a chronometer here on the screen. The chronometer, as you can see, has a 12-hour dial. It does not have a 24-hour dial. So whenever we pick up GMT from the chronometer, it always have two possibilities. It can be the AM time or the PM time. Say for example, if the chronometer shows 1000 hours, it could be 10 o'clock in the AM, that is 1000 hours, or it could be 10 o'clock in the PM, that is 2200 hours. Now this is what we know as a 12-hour ambiguity. Now whenever a chronometer time question is given to us, in that question, always there is an indication whether it was AM on the ship or PM on the ship at the time of sight. We use this AM PM indication to resolve the chronometer ambiguity. Now in the first step, we write down the two available options of GMT. Now to these two options, we apply the longitude in time. What is this longitude in time? Longitude can be converted into time by dividing it by a factor of 15. What is the use of this longitude in time? Longitude in time can be used to convert GMT to LMT or LMT to GMT. Now a doubt may arise in your mind from where we have obtained this factor of 15.
360 by
The
24.
Earth rotates on its axis, completing one rotation of 360 degrees in 24 hours. So 360 divided by 24 gives us a factor of 15. So the motion of the Earth is at a rate of 15 degrees per hour, and that is what we use to convert longitude to time. Now once we apply this longitude in time to the GMT, we obtain the LMT. Now what do we mean by apply? By apply we mean the LIT can be added or subtracted from the GMT to get the LMT. How do we decide whether LMT is to be added or subtracted? For this we use the familiar idiom longitude east GMT least, longitude west GMT best. So in case longitude is easterly, that means GMT is least or smaller and LMT will be bigger. So the LIT is added in these cases. If the longitude is west, we know GMT is best or bigger, and whenever the longitude is west, we use the negative sign so that the LMT values are smaller. So once we get the two LMT options, We check these options with the AM PM indication which is given in the question, and whatever is the appropriate option as per the AM PM indication given in the question, that will be the correct LMT. Now going back above that correct LMT, we can easily pick up the accurate or correct GMT, thus resolving the 12-hour ambiguity of the chronometer. In most of the questions nowadays, we have the GMT time given to us straight away. However, all the questions in practical navigation book are given against the chronometer time, where this method can be used to resolve the chronometer ambiguity. Any doubts coming in, beta?
Excuse me, sir. This
Go
is regarding finding out the LMT time as AM or PM, whatever you explain. This is the time matching with the question, means like either they are written in AM or PM. So we have compared this one with the question.
That's right, beta.
So this is most important part, sir, because if we are selecting GMT wrong, then our whole procedure will be wrong.
Exactly, beta. That's right. So if you get the time wrong, the entire calculation is going to be wrong.
So our LMT should be matching here in respective with the GMT should be anything, either PM or AM.
GMT can be anything, beta. What will be matching with the AM PM indication given in the question is your LMT. Because this AM and PM is on the ship, it is not on Greenwich.
Yes, sir.
Okay.
Okay, sir. Thank you.
Okay, beta. Great. Let us now try to understand the date ambiguity. Now, in some of the celestial navigation questions, a date of observation is provided, is given, but it is not mentioned, it is not specified whether the date is the LMT date or the GMT date. So there is a doubt, there is a confusion. What date should it be considered? Now remember, in all these questions, the date given in the question is always the LMT date unless specified otherwise in the question. So wherever it is not specified, the date is to be taken as the LMT date or the local date or the ship's date. GMT date is only taken when it is specifically mentioned in the question that the date given is the GMT date. Clear, beta? Any doubts in this?
No, sir.
Very good, beta. Great. Now let's move to the Almanac daily page and familiarize ourselves with the data given on the daily page of the Almanac. So on every daily page or every day page, there are two pages in the Almanac, the left hand side page and the right hand side page. Right now I have opened the top of the left hand side page. Now this one page serves 3 different days. As you can see here, this particular day refers to March 7th, 8th and 9th, Monday, Tuesday and Wednesday. So the data for these 3 dates is given on a single page. Now the first column which you see here gives you the GMT. This is the date, and then you have the hours from 00, 1, 2, 3, 4, 5, 6 up to 24.
This page is not in the Almanac, sir.
The first column which you have after the date and hour is the Aries column. And you have the GHA of the Aries given to you for every GMT hour. The GHA is given in degrees and minutes.
Excuse me, sir. Sir, this page
So
is
for
not
any day
90.
of the year, for any hour of that day, you can obtain what was the GHA Aries or what will be the GHA Aries at that particular day and hour. Now, if you want to get the GHA for a particular minute also, for a day, hour and minutes, then to this hourly figure, you will have to apply the increment for those many minutes and second. Beta, any issues coming in?
Sir, this page is not given in 1992 Almanac.
Yeah, that's 2016 Almanac, beta. The
Okay.
1992, we will refer the information given is the same.
Okay, sir. Okay.
So let us say you want to find out the GHA of Aries for 7th March, 06 hours, 30 minutes and 30 seconds. So up to 06 hours, the value is available here, 255 degrees, 23.4 minutes. For 30 minutes and 30 seconds, you have to go to the increment table. You have to get the increment from there and add that increment to this value. You will get the GHA Aries for any particular day, hour, minute and second in the entire year. The declination of Aries is not given because first point of Aries always remains on the equinoctial. Its declination is always 0. There is no change in its declination. After Aries, you have the 4 planets given to you: Venus, Mars, Jupiter and Saturn. The first figure which is given along with the planet name is its magnitude, the stellar magnitude, which gives us an idea about the brightness of these planets on that particular day. The brightness of the planets can change on a daily basis depending upon what is their location or position in the orbit around the Earth, around the Sun. The Earth and the planet both are revolving around the Sun, and depending upon the positions in their orbits, the brightness or magnitude of planets may vary. Now, under every planet column, you have the GHA and declination given to you for every GMTR. And as mentioned, in case of Aries, if you want it for a particular minute and second, you will have to add the increment. I'll show you the increment table in the coming slides. So you have the GHA and declination mentioned for all the planets. Then you come to the column on the right hand side. This is the column for stars. So you see a list of all the stars mentioned here. This list is given in alphabetical order, and this list gives you 57 selected stars. These are the 57 stars which are most often used for site taking, and they are given here for quick accessibility. Whatever date page you open, you will be able to get the star data from here. What is the data given along with the stars? They have given you the SHA, sidereal R angle, and the declination of each and every star on this page. The names are given in alphabetical order. You can see starting from A and going to B, C, D, and so on. Any doubts up to here, beta, in the data?
Sir, I just want to ask this magnitude of the planet. Sir,
Right.
where what is the correlation with this one, sir? Where we are going to use this one magnitude?
Okay. We will cover this magnitude in a separate topic, beta. It will take about half an hour to 1 hour. I will tell you in detail where it is used.
Okay, sir. And this page, sir, in our almanac, down below there is Marpas time is given. Aries column. If
I will show you the
download.
bottom page. I will show you the bottom part
Yeah,
of the
yeah,
page
sir.
now.
Bottom page, sir.
Okay.
That is also, sir, question, sir. This
Right.
this is not yet covered, but okay, sir. Just
I'll show
highlight,
you.
sir, this one.
No problem. I'll show you. I'll show you just now. Let's now go to the bottom part of the left hand side daily page. This is the bottom part. The first column is the Aries column. And at the bottom of this column, you see they have given you the meridian passage of Aries. It's given as 12 hours 53.4 minutes. This meridian passage is given in LMT. This is not GMT. The times given here with the date were the GMT times, but the time given at bottom, the meridian passage time, is in LMT. This is the LMT meridian passage of Aries. Now, under the planet
Mer
columns,
pass
you
will
see
be
4
always,
columns.
sir.
These. Go ahead,
Sir,
Beta. Go ahead.
this Mer pass time for Aries, this is in all LMT, correct?
That's right.
Only this.
That's right.
Rest other will be in GMT.
There are some more times in LMT which are on the right hand side page. I will show you when we go to the right side page.
Okay, sir. Okay.
Okay. These were for 4 planets: Venus, Mars, Jupiter, and Saturn. Under the planet column, you will see the value of V correction and D correction. Victor correction, V correction, and delta correction, D correction. What is this V and D correction for? V correction is used to obtain the GHA of a planet. The hourly GHA is picked up from the daily page. The increment for minute and second is picked up from the increment table. And after applying the hourly figure and the increment, you have to apply the V correction also. The V correction which is given here is for 1 hour. And for whatever minutes you are applying it, you will get the value for this particular V correction in the increment table. I'll show you the increment table after in the next coming slides. So this V correction is for 1 hour. The V correction which is to be used for that particular minute is given in the increment table. Same way, the D correction is applied to the declination. The hourly figure of declination is obtained from the daily page, the date page, and the D correction is applied for any minute and seconds. So this value of D given here is for 1 hour. The value which you require for any particular minute and second will be given in the increment table. So we have the V and D correction given for all the 4 planets. One important thing, if you have observed here, the V correction for Venus, this is the first planet, the first column is for Venus, it could be in the negative range. You see, it is minus 0.6. Whereas the V correction for all the other planets is always positive. Then on the right hand side, you see bottom part, right hand side, you have the SHA of all the 4 planets. Venus, Mars, Jupiter, and Saturn, their SHA is mentioned here. And along with the SHA, the meridian passage time of the planets is also mentioned. This is the LMT meridian passage of the planets. LMT meridian passage of all the 4 planets. Any doubts in this data, Beta?
Sir, there is no doubt, but I just want to ask, the first column Venus, this value is negative.
Right.
So, but in D correction, increment cable, if we go, values start from 0, 0, 0, 0. So what
Right.
about this negative side? It is only for reduction or something else?
Okay. So basically your doubt is that this V correction is negative, but in the increment table, the correction starts from 0.0 and there is no negative value in the increment table. Right, beta?
Yes, sir.
So
Yes,
what
sir.
you do is you get the increment for 0.6 plus 0.6 and put a minus in front of it. That will take care of the
Okay,
negative V
sir.
correction.
Okay, sir. Understood, sir. Thank you.
Okay. Great, beta. Very good. Let's now go to the right hand side page of the almanac. The right hand side page gives you the data about the sun. The first column is for the sun. You can see the GHA and declination of the sun given for all hours every day. So you can get the hourly figure of GHA as well as declination from the daily page. Then next column you have the data given for moon, and for the moon you have the GHA and the declination given for every hour. Now a difference which you will see for moon is you can see the V correction and D correction given for the moon on an hourly basis. It was not so in the case of planets. Planets, there was V correction and D correction for the entire 3 days. But for the moon, as I told you, moon being closest to us is the most complicated of all. So the V correction and D correction for the moon is given for every hour because the V correction and D correction changes on an hourly basis. You can see the V correction at 00 hours was 7.7 and at 01 hours it became 7.8. Same as with the D correction, 8.3 becomes 8.4, 8.5 and so on. So this is the reason why the V and D correction for moon is given for every hour. And as I told you when we were referring to the total correction table for moon, the HP, horizontal parallax of the moon, is given on the daily page for every hour. So you can see the HP of the moon given here for 00 hours, it is 59.5 minutes. This HP is used for getting the HP correction of the moon from the total correction table. Now we go to the right hand side. In the next column you see we are given twilight times. The twilight times are given to us. We have the nautical twilight and the civil twilight time given here. The twilight times and all the further times. Next you have the sunrise time. Then you have the moonrise time for all the dates 7th, 8th, 9th and one day extra. One next day is also included here. That is the 10th. It is repeated on the next page also. All these times, whether it is the nautical twilight, civil twilight, sunrise or moonrise, are in LMTs, local mean times. This is not referred to GMT. These are all LMTs and they are given against
Sir, can you repeat your
intensity of
last
the observer.
statement
You can see.
regarding LMT time, sir, please?
Just
Twilight
hold on,
section
beta.
and sunrise.
Just hold on. Just hold on with your doubt. Let me finish. फिर मैं आपका doubt लेता हूँ. Okay. Starting from 72 degrees north, for every different latitude, you see the time is different. Now you tell me, beta, what is the doubt now?
Sir, just I want to miss your statement regarding twilight, sunrise, and moonrise. This time given in the LMT, you said some call is coming, so I just missed your statement.
You heard it right, beta. All these times given under twilight, sunrise, and moonrise are all LMT times. All LMTs.
Okay, sir.
Okay. Let's go to the bottom part of the right-hand side page now. We come to the bottom part of the table. This is the first column here. The first column was for the sun. Now at the bottom of this column, you see you have the semi-diameter of the sun given. In this case, it is 16.1 minutes. Now this semi-diameter is applicable for all the 3 days. It remains same, does not change on a daily basis. So 16.1 is the semi-diameter of the moon. May be required if you are doing individual corrections to the altitude. Then you have the D correction for any minute between the two hourly figures. The D correction is given here. The increment for D correction is obtained from the increment table and applied. Now under the moon's column, you see the semi-diameter of the moon given. 3 values are given. These are the 3 different values for the 3 days. The first one for the topmost day, second one for the middle day, and the last one for the bottom day given in the daily page. So this is because the semi-diameter of the moon keeps on changing on a daily basis. You come to the right hand side. Now right hand side you see the first box for the sun. For the sun they have given you 2 parameters here. One is the equation of time. The equation of time is something related to the true sun and the mean sun, which we will discuss separately. So it is given for 2 times in a day, 00 hours and 12 hours, 11 minutes and 1 second, 10 minutes and 54 seconds given for the 7th day. And with the equation of time, you have the meridian passage time. This is the LMT meridian passage of the sun. So in this case 12:11, next day 12:11, next day it is 12:10. Coming to the right, you have the box for the moon. You have the meridian passage time of the moon given, upper and lower Marpas. Now this upper and lower basically stands for upper meridian passage and lower meridian passage. What is this upper and lower meridian passage? Upper meridian passage is on the observer's meridian. Lower meridian passage is on the observer's inferior meridian. Why is the inferior meridian Marpas time given here? This may be required or used in case the moon becomes circumpolar. So this time is used in circumpolar questions when the moon becomes circumpolar, and we are able to observe it when it is crossing the lower meridian or the inferior meridian of the observer. Next you have the age of the moon and the phase, how much percentage is visible. So the moon is on 28th day, 29th day and 00 day, and you can see it is a new moon day. The 9th is a new moon day. The visibility was 4% on 7th, 1% on 8th, and nothing is visible on 9th. So this was the information provided to us in the almanac. Any doubts coming in, beta? Anywhere?
Sir,
Go ahead.
in sun column equation of time,
Right.
timing, sir, some pages I see in Almanac during my practice session, there in one arrow mark is like that.
You're right. That's right.
Sir, so can you explain what is this and what time we can use this type of, or actually we need explanation of that, sir.
Okay, all right, beta. We will be discussing the equation of time in detail, beta. This will take about an hour or so. So that time I will explain
Okay,
you
sir.
what is the meaning of that line.
I
It is
will keep my
basically a
doubts ready
separation.
for that, sir.
Right, beta, right. We will discuss equation of time later.
Okay, sir. Yeah.
Okay, great. Very good.
Excuse me, sir.
Go ahead, beta.
Sir, in the daily pages, except this GMT, there's all times like breakfast, sunrise, sunset, twilight, breakfast are in the LMT. Sir.
Uh,
Beta, you got broken in between. Can you speak little slowly once again?
Sir, in the daily pages, all the
Right.
times except this GMT and the hourly, this all mentions the LMT time, like planets Merpas, suns Merpas, moons Merpas, twilight, sunset, sunrise, moonset. Everything is local mean time, sir.
That's right, beta. That is correct.
Okay. This equation of time doesn't say LMT or GMT, sir?
This is basically a duration of time, beta. Equation of time is 11 minute and 01 seconds. So that is why it is not referred to GMT or LMT. It's a period or duration of time.
Okay, sir. Okay, sir. Thank you.
Okay. Great. Very good. Now, when we refer to the twilight or sunrise, sunset or moonrise, moonset columns, we may come across some special symbols used in the almanac. As you can see on this particular page, this is June 14, 15 and 16, 1992. You can see here in the almanac that there are some white boxes under the sunset column and also under the twilight column. There are some slanting lines present here in the twilight column, and there are some black boxes shown under the moonset column. So what is the meaning of these special symbols? White boxes, black boxes, and the strokes, that is the slanting lines. Now, the white box indicates that the sun or moon remains continuously above the horizon, or you can say that the sun or moon is circumpolar for that particular observer. The black box indicates that the celestial body does not rise at all. So depending upon whether it is below the sun column or the moon column, it indicates that sun or the moon does not rise at all for that particular observer. Or you can say it that it remains below the observer's horizon for the full day, full 24 hours. The third symbol which is used are the slanting lines or the strokes. The strokes or slanting lines indicate that the twilight lasts all night for that particular observer. You will see the slanting lines only under the twilight column, and they tell us that the twilight stays for the complete night. That means when the sun sets, the twilight commences, and the twilight stays till the next sunrise. So this is the meaning of the special symbols used.
ये लास्ट थर्ड वन स्लैंटिंग लाइन का एक बार सर इसको एक्सप्लेन करिए प्लीज, ये मैं नहीं समझ में आ रहा सर.
Okay, beta, okay. You will become clear about this when I discuss the twilights with you. We will be doing twilights in detail. So for now, just understand that if these slanting lines are given, that means the twilight is not ending anytime. the twilight will stay there for the full night. After sunset, the twilight will start and it will stay there for the next day sunrise.
Okay, sir.
Okay. Let's now have a look at the increment table. We have the increment table for 46 minutes and 47 minutes on the screen. The first column of the increment table gives us the number of seconds. So for 46 minutes and any number of seconds, we can pick up the increment data from this part. The next column after the seconds column gives us the increment for sun and planets. The next column gives us the increment for Aries, and the next column gives us the increment for moon. Now sun and planets, Aries and moon all cover their R angle at different rates. So that is why we have different increment tables for all these three different types of celestial bodies. There is a very minute difference between the motion of the sun and motion of Aries. However, you should be very careful when you are picking up the increment. You should be entering into the correct column as per the celestial body which you are referring to in the question. Sun travels at a rate of 15 degrees per hour and the increment table is based on that rate of change of R angle, whereas Aries travels at a rate of 15 degrees 2.5 minutes per hour. Aries is slightly faster than the sun in covering the R angle. Now after these increment tables, we now have the increment table for V and D correction. So this is a combined table for getting the increment of V or D correction. Both for Victor correction and delta correction, the same table can be used. We have seen that on the daily page, the value for Victor and delta V and D is given for 1 hour. And in this part of the increment table, we can pick up the value relevant to 46 minutes. Say for example, if the value of V correction or D correction is 1.4 minutes given on the date page, then for 46 minutes, the increment for V or D correction will be 1.1 minutes.
Sir, if the value is for negative 0.6,
so then you pick up the value for positive 0.6 and put a negative in front of that beta.
so for negative 0.6, the V correction will be 0.5.
Yeah, negative 0.5 beta.
So we'll subtract.
That's right. That's correct.
Okay, sir.
Any more doubts, beta?
No, sir.
Very good, beta. Great. Excellent. So we have basically covered the almanac information. I'm closing the presentation for a while. So do you remember all these things now, beta? You had covered them earlier, but now I believe you got a recap and all these things are revised and refreshed in your mind.
Yes, sir.
Okay,
Thank you.
great. This is very, very important because if these things are there not clear in your mind and you make a mistake, the entire question becomes wrong. And very, very important concepts. Very simple, but they need to be crystal clear. Okay, great. So let's take a short 5 minutes break, beta. After the break, I'll take you to the amplitude and azimuth calculations. So let's meet after 5 minutes.
நான் குடும்பம் சொல்றா அந்த குடும்பம் சொல்றா
Hello?
Okay, beta, are we back?
Yes, sir, we are back, sir.
Okay, beta, great. Let's move ahead. Let's now see the azimuth and amplitude calculations. Let's go. Let us now see the calculation of azimuth of celestial bodies using the ABC method. The calculation of azimuth is very important for site solving because the azimuth gives us the direction of the position line. A celestial position line is always perpendicular to the azimuth of a celestial body. In all these azimuth calculation questions, the time of observation as well as the position of the observer is provided to us in the question itself. Now moving to our first component, calculation of A. A is calculated using the formula tangent latitude upon tangent of P. Latitude, as I mentioned, will be given to us in the question. What is this P mentioned here? P is angle P of the PZX triangle. This P can be easily obtained from the LHA of the body. Now, how do we obtain the LHA of the body? We have seen that the almanac has the GHA of all the celestial bodies for every day, hour, minute and second of the year. So we pick up the GHA from the almanac, apply the longitude of the observer, and that gives us the LHA of the body. If the LHA of the body is less than 180 degrees, P is equal to LHA. And if the LHA of the body is greater than 180 degrees, P will be equal to 360 minus LHA. So once P is obtained, we get the value of A from this formula. And once we obtain the magnitude of A, we have to give it a name. How do we name the A factor? A is named opposite to the latitude if P is less than 90, and A is named same as latitude if P is greater than 90. Now there is one more method which you can use to name the factor A, and that is by using the LHA. If the LHA of the body is greater than 270 and less than 090, then A is named opposite to latitude. And if the LHA of the body is greater than 090 and less than 270, A is named same as latitude. Whichever method you feel convenient can be used to name the factor A. Now one doubt may arise in your mind that if the value of P is exactly equal to 90, how do we name the factor A? If the value of P is equal to 90, this factor A is going to become 0. So the naming will not be applicable. You can easily understand it. Tangent P can be broken down into sine of P upon cos of P. The cos of P factor is going to come in the numerator, and if P is equal to 90, cos 90 gives us a value of 0, which makes the entire A factor as 0. So once A is calculated, we move on to calculation of B. B is given by the formula tangent of declination divided by sine of P. Declination is obtained from the almanac, and the value of P has already been obtained from the LHA. Using these two values, the magnitude of P is calculated. B is also named. The naming of B is very, very simple. B is named same as the declination of the celestial body. Once we have obtained both alpha and Bravo, A and B, now C can be easily calculated. If A and B are of the same name, A and B are added up and the same name is retained for C. And in case A and B are of the opposite names, C is obtained by subtracting the smaller value from the bigger value. Whatever is the smaller factor out of A and B is subtracted from the bigger factor and the magnitude of C is obtained. For naming, the name of C is retained as the name of the bigger value. So whatever bigger value is there, the same name is retained for C. Once we have obtained C, we can use this factor C to obtain the azimuth of the body. Any doubts in these beta calculation of A, B and C?
सर ये P कैसे मिलता है सर? How to find the P?
Beta, from the formula tangent declination upon sine of P. Are you asking about Bravo or Papa?
Papa sir, Papa.
Okay, just look at the first line, beta. If LHA is less than 180, P will be equal to LHA. And if LHA is greater than 180, P is equal to 360 minus LHA. Clear, beta? Getting clear?
Yes sir. LHA.
Okay, now the doubt is where we will get the LHA, right?
GHA from the Nautical Almanac. Okay sir. Okay.
Right, we just saw the daily page, beta. The GHA of all the celestial bodies can be obtained from there. To that GHA, if you apply the longitude is given to you, dr longitude, you will get the LHA of the body.
Understood sir. Understood.
Okay.
Given that if longitude east, then we add and west we subtract, right sir?
That's right, beta. Longitude east, GHA least. Longitude west, GHA best. Clear, beta? Understood?
Yes.
Very good, beta. Great. Once we obtain the value of C, we can easily calculate the azimuth using this formula now. Tangent of azimuth is equal to 1 divided by C into cos of latitude. Value of C has been calculated. Latitude is available to us. So putting these two values gives us the magnitude of the azimuth. Now this azimuth is obtained in the quadrantal notation. This is not obtained in the 3-figure notation, but in the quadrantal notation. Now we have to obtain what is the quadrant in which the azimuth lies. In the quadrantal notation, we have a north or south in the beginning, and we have a east or west in the end. So how do we decide whether the azimuth is north or south? And how do we decide whether the azimuth in east or west? So for deciding the north-south part of the quadrant, we go back to the value of C. We had given a name to C. Whatever is the name of the C, the same direction will be mentioned in the beginning. If the C is named north, we will have a north coming in the beginning. If the C is named south, we will have a south coming in the beginning. The east-west to be put in the end of the azimuth is decided by the LHA, local hour angle of the body. We had calculated the LHA. If the LHA is less than 180, the azimuth is named west. And if the LHA is greater than 180, the azimuth is named east. This is because LHA, local R angle, is a westerly measurement. When it is less than 180, the body is west of us, and when it is more than 180, the body is east of us. Clear, beta? Any doubts?
Hello, sir.
Go ahead, beta.
Sir, for azimuth calculation, I request to you, can you explain one more method for azimuth calculation, which by diagram or PZX triangle? Because in our institute, they taught us by other ways, sir. So we want to stuck with only one method, which one is the no need to remember the formula. So for you, it's only for a small thing, but for us,
Okay, beta. All right. I'm closing this down for a while. Now, beta, there is one more method for azimuth calculation, that is by using the PZX triangle. That will involve spherical trigonometry, and you will have to make the PZX triangle. I usually do not recommend that method. Okay. The reasons are two. Why I don't recommend that method? Two reasons are there. One, it is time taking, because otherwise you don't need to make the PZX triangle. If you want to calculate the azimuth that way, PZX triangle has to be made. So it is going to take more time. Okay. And time is a rare commodity in phase 1 exam. If you run short of time, the paper will be left. So that's one reason. Second reason is, beta, in practical navigation book, most of these questions, the azimuth calculation is done using ABC method, which I had showed you here. So most of the paper checkers, they are accustomed to, they are used to seeing the solution in this format only. Okay. So if they see PZX triangle being used, now if I'm checking the paper, I know that you have done it correctly, but you may find it difficult with some other paper checker, right? Because in the book, the most common method is used is the ABC method. So I would recommend use this method only, beta. However, when I do the PZX triangle with you, rational horizon numericals with you, once you are understanding that topic, you will be able to calculate azimuth by that method also.
Sir, I fully agree with your thing, sir. This is more easier, but the teaching way here, no, they are already start everything from there. So we just want to clear, okay, what is the way they are doing. We just try to understand the things because everywhere they just draw the PZX triangle and by the cosine formula try to find out the things. So that
No
is the reason
problem.
I just try
Just
to understand, sir, here, sir.
I will explain to you, no problem. For that, just wait. Okay. Because
Okay, sir.
our
Okay, sir. Yeah,
target,
sure, sir.
our prime target, our first target is to get full marks in question number 5 and number 6. So first collect those
Okay, sir.
marks. Then I will explain
Yes,
to
sir.
you how azimuth is calculated using PZX also. For that, just hold on. Be
Yes, sir.
patient.
Okay, sir.
Okay. Because before that, I will have to explain to you what is rational horizon diagram, how it is made, what are the different parts of the PZX triangle, how the PZX triangle is made. That is going to take some time.
Sure, sir. Continue with the
Okay.
class, sir. I will write down my doubts.
Okay. All right. Let's go back.
Sir, I think somebody from our group, Mr. Rahul Sharma, got disconnected. He's sending message
Okay.
in the group that he is not able to connect back.
Okay. Rahul is not able to connect. Okay. Let's give him a couple of minutes. He dropped a message in the group. Huh? Okay. Let me see. Okay, let me help him out.
सब चीज का की है सर इसका भी की है
Let him try out the steps. Let's see if he can get back. We'll give him a couple of minutes if he is able to come back. Very good. Otherwise, we'll continue. Looks like he is taking time. Not able to connect back yet. Okay, no problem. We will continue, beta. So I'll explain to him once he comes back. Now, while working celestial navigation questions, we have to calculate the R angles of celestial bodies. These R angles could be GHA, the Greenwich R angle, LHA, the local R angle, SHA, the sidereal R angle, or right ascension. Right ascension is something which is opposite to SHA. SHA is measured in the westerly direction from first point of Aries. Right ascension is measured in the easterly direction from first point of Aries. Now, whenever we are calculating any of these R angles, sometimes the candidates are confused because these values of R angle may go into negative range. Depending upon the longitude, the value of R angle may go into the negative range. And sometimes the value of these R angles may go more than 360 degrees. So whenever such a thing happens, always remember the value of R angle, GHA, LHA, SHA or right ascension always remains between 000 and 360 degrees. If at any point of time the value goes outside this range, you can add or subtract 360 degrees to bring it within this range. Please do not add any other value, 90, 180, 270. 360 is the only figure which is added or subtracted to bring the R angles between the range of 000 and 360.
Sir, all four angles move towards west, you said, correct, sir?
The first three are westerly angles, beta, GHA, LHA and SHA. Right ascension is measured eastwards.
Okay, sir.
Okay, right ascension is normally not used in the questions.
सर काफी मिस हो गया सर
नहीं बेटा कुछ भी मिस नहीं हुआ. We waited for you. This is the only slide which is shown. If you have understood this, then you are perfectly in order.
Value of R angle. Okay, sir. Got it, sir.
Okay. So we waited for you. This is the only slide I showed. Now moving on to the amplitude correction. Let us now go into the calculation of amplitude of a celestial body. Amplitude is basically the direction or the bearing of a celestial body when it is rising or setting. Amplitude can be easily calculated using a very simple formula. Sine of amplitude is equal to sine of declination divided by cos of latitude. Now when we calculate the amplitude using this formula, the amplitude is obtained in a special format. The formula gives us the magnitude or value of the amplitude, and this magnitude has to be named east or west in the beginning and north or south in the end. Now this kind of a format is not used anywhere else in navigation. In quadrantal notation, we have a north or south coming in the beginning and a east or west coming in the end. But in the amplitude calculation, we have a east or west in the beginning and a north or south coming in the end. Now, how do we decide whether the amplitude will have a easterly or westerly direction in the beginning and the amplitude will have a north or south direction in the end part? So for this, the east and west coming in the beginning is decided by the rising or setting of the body. If the body is rising, it will obviously be in the easterly direction, and if the body is setting, it will obviously be in the westerly direction. The north or south direction to be put in the end is decided by the declination of the body. Whatever is the name of the declination, the same will be the direction of the amplitude also. Now say for example, if you get a value of the amplitude east 10 degrees north, this simply tells us that from the easterly direction we have to go 10 degrees northwards. That gives us a direction of 090 minus 10, 080 degrees, giving us the three-figure notation direction of the amplitude of the body. Now in the amplitude questions, usually the time of the observation is not provided to us. Now we need to get the declination from the almanac. So how to obtain the time of observation? Now for this, we obtain the LMT of the rising or setting of the body from the almanac. The rising and setting times of the bodies are provided to us in the almanac. So the LMT of rising or setting is picked up. We apply the longitude in time and obtain the GMT of rising or setting of the body as required. Once the GMT is obtained, we enter into the almanac using the GMT and obtain the declination of the body to use in the formula. Any doubts in amplitude, beta?
Sir, can you show the first step, obtain LMT of rising and setting from almanac?
Okay.
Is moonrise, moon set time or sunrise, that time is taken?
That's correct, beta.
As per
We just saw
latitude.
in the daily page the moonrise, moonset, sunrise, sunset time is given. So that time is picked up from the almanac, and that is step 1.
Okay. Okay, sir. Okay, sir. Understood, sir.
Okay. Great. Very good. So with this, we complete our basic concepts, beta. The basic concepts are done. So everything refreshed in the mind?
Yes, sir.
So beta, all these things which I revised with you today, was it comfortable? High level alarm not coming, right?
No, sir.
No, sir, not
All good,
common
sir.
time. I'm also okay.
Okay, all right. Great. Okay. So now beta, the next topic which comes for us is the site solving topic. So we are going into these 5 methods, Marpas, Long by Cron, Intercept, X Meridian and Polaris. I believe let's keep the site solving the first method for the next class. Today if I do with you, it may get little overwhelming. What do you say?
Yes, sir. Yes, sir. Much better.
Okay, all right. I thought so. So let's keep it for the next class. In the next class, we will be covering up at least the first two methods will be covered up. So these are the Marpas and long by Cron, and you will get homework for doing these two questions. First, I will tell you to do practice these questions from the PracNap book, the simple question answers. And once we have completed all methods and you have practiced the basic ones, then I will give you a second assignment, giving you the higher level questions. So what about the GC and composite assignment, beta? Have you completed, all of you? Good. Others, beta, चल रही है, कर रहे हो? Going on?
Going on.
Still in progress.
Going on, sir.
Okay.
अभी time लग रहा है.
It's okay, take your time. But remember one thing, beta, don't leave any question unpracticed from the assignment. Do the assignment once. If you had difficulty doing a question and you had to take help from the solution first time, do at least those questions again. The practice of the assignment should be such that you need to be 100% confident that if any of these questions comes in the exams, 100% I will be able to get the correct answer. So that should be your preparation level, beta. This is what is required to pass in the exams. So practice the assignment. If you have difficulty in answering the question or you took help from the solutions, practice it again, once again. Keep on practicing till the time you are 100% confident of doing them right. Right, beta?
Yes.
Right, sir.
This is the effort which is going to pay you back during the exam time. Okay, so that's what differentiates the difference between pass and fail. So practice it well. Huh? Okay, great. So let's stop it here for today.